Hello, good morning, everyone. Now, as you know that we are discussing about projections of planes unit number 4. Okay, this is our third session. We are going to discuss two inclinations. The plane making an angle with HP as well as with VP. Okay, now let us see a rectangular plane surface. A rectangular plane surface of 50 mm side by 30 mm is a rectangular plane surface of 50 mm by 30 mm is in the first quadrant. As you know that if any object in the first quadrant, its front view should be represented above the reference line and its top view should be represented below the reference line. Okay, one more time. If any object is situated or positioned in first quadrant, we will represent its front view above the reference line and the top view below the reference line. Okay. Now coming to problem. A rectangular plane of 50 by 30 mm is positioned in the first quadrant and is inclined at an angle of 60 degrees to the HP. Now take this rectangle surface of 50 by 30. Okay, we will place this rectangle as resting on its shorter side on HP and making an angle how much? 60 degrees with HP. And second inclination is 30 degrees with the VP. 60 degrees to the HP will represent as theta and 30 degrees represent as pi. Okay. Now let us assume how to solve this type of problem. Whenever a plane is making both the angles, angle with HP and angle with VP, we have to assume the problem is solved in 3 steps. We have to think whenever any plane is inclined to HP and also inclined to VP, that problem is solved in 3 steps. What we exercised yesterday's last class is when any plane is inclined to one plane and perpendicular to other plane, that type of problem is solved in 2 steps. Either it is inclined to HP perpendicular to VP or inclined to VP perpendicular to HP. We solved that type of problem in 2 steps. What is first step? In the initial position, we assumed the total plane is resting on HP. If that plane making an angle with HP, we should assume in the initial step the total plane is resting on HP. And if any plane is resting on VP like this, if any edge or any corner or any surface, any portion of the surface is resting on VP, we should assume the total plane is resting on VP and perpendicular to HP. Okay, that all notations we have discussed in last class. Now we will solve. In this class, we will solve this problem. A rectangular plane surface of 50 mm by 30 mm is positioned in the first quadrant and it is making an angle 60 degrees with the HP and let me see 60 degrees to HP and the same plane making an angle 30 degrees with VP. 60 degrees with HP, this inclination is 60 degrees with HP and the same plane making an angle another 30 degrees with the VP. How to solve this problem? When the plane is making both the angles, when the plane is making angle with HP and angle with VP, we have to solve that problem in 3 steps. In what is the step? What are those 3 steps? Actually, the position is placing like this. Now, let us remove inclination with VP. Let us remove the inclination with VP. Then the plane is like this. What you are observing? The plane is inclined to HP and perpendicular to VP. Yes, inclined to HP and perpendicular to VP. Okay, now we assume another position. We remove another inclination also. If we remove inclination with HP, the plane is positioned like this. The plane is positioned like this. What is this position? In yesterday's class we discussed. What is this position? Whenever the plane making an angle with any other plane, when the plane surface making an angle with any other plane, in the initial position, we have to position as the plane is totally resting on HP or parallel to HP. And what about with VP? Perpendicular to VP. This is very, very important point. Okay. So in the initial position, the total plane is, we have to assume the total plane is resting on horizontal plane and perpendicular to vertical plane. Okay. And an important thing is we have to mention what is the condition, how it is resting. The condition is we have to draw line perpendicular to the XY line. Okay. In the initial position, the top view, it's a top view gives the true shape and size of the plane figure, and in front view we will observe a straight line of 50 mm length. Okay, let us start the problem. Graphical representation. Okay, this is reference line XY. This is reference line XY. Very good. Now, what is the position? In top view, in the initial position, we are assuming that the total plane, rectangular plane of side 50 by 30 is resting on HP and perpendicular to VP. In top view only, we observe the true shape and size of the plane figure. And this edge, the shorter side, perpendicular to XY line. Okay, perpendicular to XY line. This is 50 and this is 30 and another side parallel to this 50. Now we will write A, B, 4 corners, A, B, C, C and D. Okay, what is this dimension? 50. What is this dimension? 30. Has given 30. Okay, now what about front view? It's a front view. Okay. Right. Front view should be represented on XY. On XY. Okay. We take front view as blue color. Okay, blue color. What is the notation of this point? The notation of this point is B dash comma A dash. Why B dash comma A dash? We are observing this point from this direction. Therefore, B is visible and A is invisible. Like here C dash D dash. Okay, C dash D dash. This is front view and this is the top view. This top view is true shape and size. The top view having true shape and size. Okay, this is about the first step. Now we will move to second step. What is second step? What we assumed, actually the plane is like this. The plane is making an angle 30 degrees with HP and 60 degrees with VP. 30 degrees to VP and 60 degrees to HP. What we assumed, initially we removed angle with VP and we kept angle with HP. And what? Again we removed horizontal plane inclination. Now we will make the plane making an angle 60 degrees with HP and perpendicular to VP. Okay, initially we kept like this, but as given in the given data, as given in problem 60 degrees with HP, the plane should be tilted like this. Okay, so what we have to do here is the first step of front view. The front view, what we have drawn, B dash A dash comma, B dash A dash to C dash D dash line should be making an angle 60 degrees with HP. That means with XY line. So we have to take B dash A dash here and 60 degrees. How much length? Equal to first step length. How much length? Equal to first step length. What is this? C dash D dash. Inclination is 60 degrees. Okay. Now projectors. We have to draw projectors. What we will give, again projectors. From this A point and D point to here, and B point and C point to here. What is this point notation is? A1. This is B1. This is C1. This is D1. Now see, this is the second step top view. This is second step top view. But this is true first step top view having true shape and size. But in second step top view, what we are observing? This is 50, not 50. But this is 30. The 30 dimension is remains same. But whenever the plane is making angle 60 degrees or something with the HP, definitely its length is reduced in the top view. That is reduced size, reduced shape. Reduced size and reduced shape. What? Next, second step. What we assume? What we assumed? Plane is inclined to HP and perpendicular to VP. Okay? Inclined HP, perpendicular to VP. What is the third step? Very carefully, listen carefully. Whatever the edge is perpendicular to HP, whatever the edge is we kept perpendicular to HP, that line length is not remains same. That line length is remains same. Yes, this is the length remains same. Now we have to keep this line with the given inclination. What is given inclination? 30 degrees. What is the given inclination? 30 degrees. Okay, we will take $30 degrees. What is that? 30 degrees. What is happening? What is happening? Right. So inclination 30 degrees. Inclination 30 degrees. And what we have to do? This A1B1 length should be taken on this line. What is this? A1, B1. We have to draw this line perpendicular to A1, B1. Same dimension we have to keep. C1 and D1. What we have to do now? We have to do projectors. We have to draw projectors. Till this is B1, we have to keep B1 up to projector coming from B1 dash. This is B1 dash. Okay, and now what about A? A also similarly from A here A1 dash. What about C1? Projector passing from C dash, this is C1 dash. And what about D? D also coming like this. D also coming like this. D also coming like this. So this is about D1 dash. This is about D1 dash. Okay. This is D1 dash. This is D1 dash. Now we have to join A1 B1, B1 C1, C1 D1 and A1 D1. Okay. Now see, observe, this is the final front view. This is the final front view of the plane figure. Okay, so how we solved this problem? Initially, the plane making an angle 30 degrees to VP, 60 degrees to HP. But we removed inclination with VP and we kept inclination with HP. Again we removed inclination with HP, and finally we got this position in the initially. So initially we assumed the total plane is resting on HP perpendicular to VP. So in top view only we observe the true shape and size of the plane figure, and in front view we observe a straight line. We have, for that reason, we drawn true shape of the plane figure in top view, and the front view is a square. Sorry, front view is a line. And in second step, what we did is the plane is tilted like this to the required inclination 60 degrees. The same length line B dash A dash to C dash D dash line making angle 60 degrees like this. On top view we observed a reduced shape and reduced size. And in third step, what we did is the edge which is remains same in length and perpendicular to in both the steps, we have to keep that edge 30 degrees to the XY line. That means 30 degrees to the VP. So we transformed the distances A1 D1 here and B1 C1 here perpendicular to A1 B1 line, and we completed, and that means we transferred the second step top view to here, and we projected to get final front view. Final front view is A1 dash B1 dash C1 dash D1 dash to A1 dash. This is about a plane making an angle 60 degrees to HP, 30 degrees to VP. That means a plane making an angle inclination with both the planes, both the principal planes. That's why this type of problem are called oblique plane problems. Okay, students, oblique plane problems. We will discuss corner based problems and circumference problems and special problems in coming classes. Okay, thank you everyone. Thank you.